Hey, welcome back. We're talking about how probability distributions transform when you either add the same amount to every single piece of data or multiplying it out. So we're going to summarize and formalize what's going on here, and then we'll do an example down here. So in terms of adding and subtracting a constant, so remember that's like when we added $10 onto everybody's salary. The shape, as we saw in the dot plots, stays the same. Same shape, just got moved. It just picked up and moved over. So the center ends up moving up as much as what we added. So you're just going to end up adding or subtracting C to that. Okay. Now for the variability, remember your standard deviation, nothing changed because since all I'm doing is taking this and just picking it up and moving somewhere else, the spread here isn't changing at all. So that is also going to stay the same. Now, when we multiplied or doubled everybody's salary, what happened? Okay, the shape, as you saw, it got bigger, but the shape stayed the same. In a lot of ways, I usually have somebody who will say, this is just like what we did in geometry. And I said, well, yeah, I mean, notice, it's transformations. We're just doing it with a data set and not a shape. So sometimes making that connection can be helpful for you. Now for center, we ended up multiplying or dividing by our C value. And then for your variability, what we ended up doing is the same thing. Because again, you're spreading out the data more. Because when we're taking, this is my data here, okay, if I double this amount, it's going to go twice as far away. Sorry, I'm trying to make sure I get the perspective right. So anyway, so yeah, if it's this for normally, it's going to, the top number is going to go here, where the bottom number is only going to go a little bit, and so that gap gets bigger. Okay. So for your check your understanding, we're taking a look at billionaire data. So X is the number of billionaires in a randomly selected state. Based on the current records, the probability distribution is down below a random variable, and so sometimes they'll give you all of this, but guess what? They already give you all the data down here. So before you freak out, make sure you read it. The mean is 12.68 millionaires per state. Standard deviation is 29.02. Suppose the law is passed requiring each billionaire to give $1 million to their state, and let Y be that. So take a look at the rest of the questions. Come on back, and we'll check your answers. All right, so the first question was, consider the graph of the probability distribution. How would those shapes compare? Now, in the first video, I actually did show a dot plot, so this shouldn't be that big of a stretch. The shapes of both X and Y are going to stay the same. So even though you're adding $1 million, or everybody's paying out $1 million, it's going to end up, you know, the shape's going to be the same. Why? Because it doesn't matter what we do. If we add a constant or multiply by the constant, the shape's just going to stay the same. They might get bigger or smaller, but the shape's going to be the same. So the second one asks for what is the mean of Y. Now remember, for the mean, you're going to do, which is up here, the center, okay? You're going to do whatever is happening to the data. So if you're adding something to all the data, then you're going to multiply the mean by it. If you're going through and you're dividing or multiplying every piece of data by a constant, that's going to happen to your mean as well. Okay, so down here, we're going to go through and we're going to take the mean. The new mean is going to equal to $1 million times the old mean. So that's going to be $1 million 12 times 12.68. So the average amount of money that each state should get is $12.68 million. Now, you know what's coming next, standard deviation. So you're going to go through and do the same thing there. $1 million. Now, since it was multiplying, you're going to multiply here. So you're going to take $1 million times the old standard deviation of 29.02. And so that means we're going to get, we have a standard deviation of 29.02 million. So just a little bit above $29 million. And of course, what does that mean? And it means that the amount of money received by a randomly selected state typically varies by $2.902 million from the mean of $12.68 million. So, and yes, it needs to be kind of in that form. Now, in terms of this, they're saying, okay, now what happens if everybody's going to pay $500,000 to help fix the roads? Seems low, but you know, $12 million for a state is not exactly a lot, which is sad. But anyway, moving on. Get politics out of your podcast, Mr. Hayes. Gotcha. So the shape's going to stay the same here. The mean's going to shift down because we're taking $50,000 out of everybody's pocket. Down we go. And then in terms of the standard deviation, it's still going to stay the same because remember, when you shift things, the variation stays the same because the spread stays the same. All right. And that covers up what we're going to talk about with transforming probability distributions. Anyway, if you have questions, as always, put them down below. Hit subscribe on the next exit screen. Hit a like here and there. All of that helps me help you. Wow, that sounds like a canned line. I'm sorry about that. Anyway, we'll talk to you later.